Welcome back, and let's start. So, after the last session, we discussed about we have seen a briefing about what is Docker and Kubernetes. So, we have gone through why we need the Docker, what is the main, like previously we used to have the physical servers, and later we have gone through the virtual machines. From the virtual machines, how we are going with the Docker. So, the point what you need to understand here is, so whenever we are discussing about the Docker, first things first, the most important concept is hardware virtualization, where we have discussed about the VMware ESXi. And the most important one again is there are two types of virtualizations. One is bare metal virtualization and the other one is the hosted virtualization. These are the concepts that we have seen. And in this session, what we are going to discuss is, so what is Docker and what is this software virtualization? What is a container? Okay, these are the things that we are going to discuss now. So when we are discussing about this containerization platform, so first things first, how many types of, like, what are the different containerization platforms that we are having? One is Docker, that everyone knows about that. But what is the containerization platform that is inbuilt in the Linux? So in the Linux operating itself, when you go for the Linux operating system, we will have an inbuilt containerization platform. Can anybody know, or else did anybody know about that? Anyone? So when we install this Red Hat Linux or Ubuntu Linux, there is a specialized containerization platform that is called as Container D. So Container D is an inbuilt containerized platform that is available for the Linux operating system. Now, then why we are going for the external? So Container D will have certain limitations. To overcome this problem, we are going with the Docker. So Docker is very well known and very easily accessible containerization platform. Now what we are discussing about the Docker. So in Docker, what we are discussing in Docker, first thing is how to install Docker in Ubuntu OS, also Ubuntu operating system and Windows operating system. And later Docker architecture and then Docker lifecycle. So these will comes under the basics of Docker. Now, let me go for the next one. So before we going to learn about the Docker, where exactly this Dockerization or orchestration will comes into the picture, containerization or orchestration comes in the picture. Now we have an IT service company. So yesterday also I said you the same story. There is an IT service company. Now for this IT service company, so who will be there? Developers will be there and they will develop the code. Okay, after developing the code, what they are going to do? So for example, there is a developer. Okay, full-fledgedly he has developed certain application and he is going to push that developed application into the version control that is called as GitHub. Into the GitHub, he is going to move this code. So once he has moved the code into the GitHub, from there, what is going to happen? So if you see the SDLC, what is this SDLC? Software Development Lifecycle. Okay, software development lifecycle. So it explains about the software or else an application from the scratch, how it has begun and how it is available for the end user. Okay, and later on, if at all, if any updates are available, how we are going to provide those updates. Okay, SDLC, software development lifecycle. The name itself says that there is an application. So if that application has to be available for the end customer or end user, how this application will be forwarded, or else how this application will be step by step, how it is going to be grown, or else how it is going to be developed. So if you see here, we are having what I can say. First one, the application should be deployed, or else first the application should be developed. Either it might be in the application platforms like Java Oracle, oh sorry, Java, Python, or else Ruby in any of the application platform, the application has to be developed. Once it is developed, then it should be moved. First of all, it should be tested. So whether the application is working fine or not, whether if it is working fine. Okay, so if all the testings are done successfully, then it should be deployed. Okay, so let us see what is the step-by-step procedure. First, development. Okay, in the development, what are the tools that we are using? Okay, in the development, we are going to use the tools like for version control, we will use Git. For the version controlling, we are going to use Git or Bitbucket, any Git related tools, version controlling related tools. Later, after developing, so we need to make builds. So if you go for Java, it is Maven. Okay, so on .NET, it is a different one. For Windows .NET, that is different one. And there is Node platform for the, or also npm for the packaging manager, Node packaging manager for the Node applications. So like that, there are certain tools which are helpful for you to develop the software. So once the builds are generated, then we are going to use SonarQube. Okay, or else in between the code itself, after code, before going into the build position itself, we are going to use SonarQube to test the code quality. So how much quality is, like, what if there are any repetitions of the code are there, what is the quality of the code. To test that, we are using the SonarQube. Later we will be going into the Maven or else any build tools to build the applications. And from there, from the Maven, the build is completed. Now it should be forwarded to the, or else it should be deployed in a server. It should be deployed in a server, or it should be deployed in the Docker. Here comes the main picture called as Docker. Okay. So now the point what you need to understand, if I have to build the server, or else if I want to create the Docker, so we can automate the things either by using shell scripting, or else we are going to use certain pipeline called as Jenkins, Bamboo, like that. We are going to use the pipelines to make the end-to-end availability of the application. Now, to build the infrastructure, we are going to use a tool called as Terraform. So this will be helpful for infrastructure management, to create the servers, or else to create the servers, to create the VPC or virtual network in cloud. Like that, we will be using Terraform. From there, once the server is built, then what we can do for the application management or else management configuration, we will be using Ansible. Ansible will be used for installing the application on the servers. For example, if you are having some 10 servers, in all the 10 servers, you want to install the application at a time. So if you want to go one after the another server, it is going to take a lot of time. But if I use the Ansible as my management configuration tool, then it will be very easy for me to install all the softwares on all the computers or also on all the servers at a time. So Ansible will be very handy for you. So once Ansible we are using, we will be installing Docker, Docker on all the servers. Okay, how many servers? Maybe it might be some 10 servers, 15 servers. It doesn't matter. So containerization platform we are going to install. On the top of that Docker, to manage those containers, we are going to use the Kubernetes orchestration platform. So here comes our entire concept. Whatever the concepts that we are discussing, the entire concepts comes here. So if you see in the DevOps, these are the what I can say step-by-step process that we are going to follow, starting from Git to Ansible, and later comes our entire terminology or technology that we are going to discuss. Either it might be Docker, or else it might be Docker and Kubernetes. And once the containerization is done, then we will be going for the monitoring tools. So what are the monitoring tools that we are going to use? We are going to use Prometheus or Nagios. Okay. And then for getting the charts, for the graphical charts, we will be using Grafana. And inside the Prometheus itself, we will be having Alert Manager. So with the help of these things, what we can do, we can monitor the applications that are running inside the pods, or else that are running inside the containers very easily. So monitoring is done, and finally that will be released into the production so that the end customers will be easily accessible. Now, if there is an update, this is the entire life cycle of the application. In between that, we are going to use the Jenkins, which is a very, very, very important tool in the entire development process. Jenkins is the what I can say development tool, or also Jenkins is the tool which we CI/CD pipelining tool, which will be helpful for the end-to-end automation of your application. Now, this is how your what I can say SDLC, software development lifecycle, will be working out. And there are two forms of SDLC. One is called as waterfall model, and the other one is agile model. Nowadays, everyone are using the agile model. Previously, in good olden days, we used to have the waterfall model, but that is not very, very convenient for the software developers. So they have moved into the agile model. Now, what is the main difference between waterfall and agile model? Waterfall model, whenever you are working with this waterfall model, if there is an application running and if there is an update available, so in a single service, there is an update available. Now, in the waterfall model, what you have to do, you have to modify the entire application. You have to stop the entire application and you need to update all the related services and everything. So that's the main drawback of waterfall model. From the beginning, we have to start it and then we have to go ahead with the with the application. Now, when you go to the agile model, in agile model, if you are having an update for a single service, then you can just modify that single service. So it is very convenient for the developer. So nowadays, everyone are going for the agile model itself. So this is the main SDLC technology which we are using, SDLC model that we are using. Among this SDLC model, we are going for a Docker and Kubernetes. What is Docker and what is Kubernetes, that we are going to see. Okay. Any questions from your end? Is it clear for you? Can I go for the next one? Guys,
Yes.
sorry. Yeah, let us get back to the next thing. So the next thing is, first we need to discuss about the Docker. So what is this Docker? So every time we are discussing containers, orchestration tools, pods, replica sets, deployments, Docker volumes, Docker. But basically what you need to understand here is container. So what is a container? Container, what I can say, it's a process in the Docker environment. Okay, it is a simple process. It is a process in the Docker environment. Whenever you are running the Docker application, if or also whenever you are having a Docker, on the Docker, if you want to run an application, the application will be running inside the container. So if you are having distinct type of applications, those applications will be running inside these container processes. Now, there is a very good documentary which is given by, let me tell you what exactly is container, by Julia Evans. Okay. So if you go through this document, or else if you go through this blog, you can clearly understand. So why containers and what is a container? Inside the container, what we used to have. So in general, you will have certain, what I can say, uh, certain processes that are running. So let me go ahead with the C groups. So there will be container groups will be available and namespaces will be available, depending on what one container is distinguished with the another container. So I am having certain C groups and in Linux environment, and there will be certain namespaces. Depending on that, the containers will be divided. This particular container process is running this particular application, and this particular container process is running this particular application. So here you can go through this particular document, which will be very handy for you. Okay. And there you go. So here you can see what even is a container, namespaces and C groups. Before we diving into the containerization platform, first of all, you need to have this particular understanding. So what they are saying, the word container doesn't mean anything super precise. Basically, there are a few new Linux kernel features that let you isolate the processes from each other. So I said, so how containers will be isolated from one container to the another container depending on the namespaces and C groups. When you use those features, you will call it as a container. So basically, a container is a process that is running an application. Now, how one container will be divided with the or else isolated with the another container means depending on the namespace and the C groups. So what is a namespace? Let's say we wanted to have something like virtual machine. Of course, container is also a virtual machine. In virtual machine, we are going to run certain applications, and these applications will be isolated from the another virtual machine applications. But when you compare the virtual machine, the virtual machine is high end, like it is heavy weighted. So when you come to the containers are light weighted. So that's the reason we are going with the containers. So let's say we wanted to have something in the virtual machine. One feature you might want is my processor should be separated from the another process on the computer. So how one process will be separated from the another process? So the feature called as namespace. One feature Linux provides here is namespace. There are a bunch of different kinds, like process ID. So in Linux, when you go for the application related things, one application is running. So that application will have a process ID. Okay, so in a PID namespace, you become PID, and then your children in the sense the process children or other processors, all of the other programs are gone. In the networking namespace, you can run the programs on any port you want without it conflicting with what's already running. In mount namespaces, you can mount and unmount the files without affecting the host file system. See, what they are trying to say here is whenever you are having a Linux operating system, in the Linux operating system, you will be running certain applications. So that applications, let me run one of my Linux server so that you will understand this process very easy. Okay. So what I'm going to do here is, just give me a second. Hold on. Okay. Once I logged into the system, see here we have a server or else an instance. Now this is a Linux operating system. So in this Linux operating system, we will be having multiple processes that are running. So what I can do here right now, let me go back to this. Look at here. It is correct only. What is the public IP that is given for this server? This is the one, right? SSH hyphen I at key.pem Ubuntu @ yes. All right, we are inside our server. Okay, sudo su hyphen. Now here you can see ps hyphen ef. Now when I run this, we will get so many number of processes. So these are all comes under the namespace only. Whatever the process that are running depending on this PID, those are all comes under the process. So what is PPID? Parent process ID. Okay, this is the parent process ID and PID is the child process ID. Now that is what she is telling here. If you see what she is trying to tell here is my namespaces are nothing but the processes in Linux. In a PID namespace, you become PID and then your children become the other processes. In the networking namespace, if you go for the networking namespace, there will be different types of ports. For example, if I install an application, so what I can do, apt install -y nginx. Okay, so I'm going to install an application or else a web server called as Nginx that will be running on port number 8080. Okay, so now if you can see here, my server is listening to netstat. Is it available? Apt install -y net -tools. Now here you can see we have a port number that is assigned to my application. That the port number is 80. Netstat -tuln. Look at that. 80 port number is already assigned. Port number 22 is already assigned. Port number 68 is also already assigned. So I cannot run any another application on the same port number. If I run the application, I am going to encounter with a conflict. So that is what. So previously, whatever you are seeing the PID, those are the namespaces that are belonging to the Linux operating system. In the networking terminology, these ports are very important for you to distinguish the processors. So one processor, Nginx process is running on the port number 80. SSH process is running on the port number 22. So like that, then there will be the namespace, networking namespace. You can run the programs on any port number you want without it conflicting with already running. Okay, so the next one is hardware. Hardware, like if you want to mount any hard disk or else any storage device to your server, then you can go for the mount spaces. So in the same manner, here also the processors, whatever the containers that are running in your Docker environment, they are the process with a different kind of namespaces. So if you run two containers with the same name in the Docker, it won't be accepting. So if you see, already I have a Docker in my server. I will tell you how to install the Docker, but just I want to show you. Docker ps docker run -it. I will tell you about all these commands. Don't worry. -name web app and images nginx. So I'm running a container in my Docker environment. So here you can see Docker ps. We have a container running, that is web app. Web app is the container name. If I try to create docker run -itd -name web app, and I will try to create another application. For example, open JDK 17. Okay, for example, if I try to open this open JDK 17 application, or else -alpine. Okay, with this particular image I want to create. Let me go to Docker Hub. I will tell you about this Docker Hub also, don't worry, but it's a beginning stages, that so I am not going very in deep into that. Open JDK 17. Okay, this is the image which I want to, I want this image to install my uh, another container. Okay, so let me go with this. Any image you can go with this. I don't have any problem. So what is the tag that we are
I
having?
have one question.
Mhm.
Basically, if this image is built by persons, right? So, basically, means is this image is maintained by the any company or the people? That is one of the question. And if we are using the direct this images like OpenJDK 17. So
Mhm.
I have seen that in my projects they are used the Alpine images. Means they are just using the raw Alpine images and they build all the things in that Alpine image. They are
One
not
second.
using the
One second.
Node.js.
One second, we are not coming into the images right now. Once we are in the images, whether we will create the images or else somebody are going to manage or maintain the images, that you will come to know. Right now, from the Docker Hub, we are fetching the image and we are creating the containers. We are not going in deep like into the Docker images right now. Okay. First of all, what is a container? First, you need to understand that. So a container is a process in a namespace. So if I want to have multiple containers in the Docker environment, the namespace constraint is very much highlighted. Why? Because see here, so already I have a container with the name web app. So even though I try to pull the Docker image and trying to create a container with the same name, so the Docker is not accepting it. So how you can isolate one container from the another container depending on the namespaces that is provided. So the namespaces are nothing but the names that are given to your containers. So first thing, what you need to understand, what is a container? Container is a process which is running the application inside a namespace. Now, if I want to create another container with the same name, Docker will not accept it. Why? Because in the namespace, we need to have only one container with the same name. So that is about your containers. And the next one is C groups. There is one more option depending on what we are going to distinguish the container. There is C groups. So we have made new magical word with new processors and socket that is separated from our word. So what if you want to limit your how much memory or CPU one of your program is using? For example, we are going to these C groups are nothing but which will assign the service resources or resources for our containers. But right now we are not, so these C groups are nothing but resource limit, how to limit your resources. Okay. So depending on that, we are going to check this container can be using this particular amount of CPU. This particular container will be using this particular amount of RAM. So in this manner, we can distinguish them. So now what are containers? Okay, now that you have seen two features, you might think I can build a bunch of scripts around all these features and have something really cool. It would be really lightweight. So a container is a lightweight and its a process would be isolated from each other. So simply which I have to say you here is a container is a process and it's a lightweight process which will be holding the applications that are running all your servers or else all our services. So that is called as a container. So if you go through this particular concept, this particular entire document, you will clearly understand what is a container. Now, if I have to say you in a pictorial manner or else in a graphical manner, what is a container? Okay, just forget that we are talking about the containers. Just understand that. For example, we are having a Chrome browser. So this is my Chrome browser. I have opened this. In this Chrome browser, so on one tab, I can open Amazon website. That is my AWS website. So on the another tab, I can open the portal azure.com. Now, if you compare this tab to the other tab, so which are distinguished, this particular AWS tab is an isolated tab from the Azure tab. So whatever the data that is present in this particular application or else website tab that is completely different from the data that is present in the another tab. So if I go back to somewhere like Java related things, okay. So here the data is different. Now, if you see, there is a single application. What is this application? It is nothing but your Chrome application. Inside the Chrome application, you are having multiple tabs, nothing but the multiple processes that are running. Each tab consisting of its own data. In the sense, each process will have its own data. In the same manner, when we are discussing about the Docker also, Docker is an application or else containerization platform. Just it is a platform which will hold all your application containers. How this Chrome is holding all your what I can say websites or else web application, in the same manner, Docker is also going to hold all your application related containers. Okay, so but one container is completely isolated from the another container. Okay, this is how it is going to work. Now, what exactly? So what is the basic concepts that we need to cover in Docker? The first thing is Docker installation in the Ubuntu operating system. How we are going to install the Docker? It is very simple. Either you can go with the step-by-step process which is given in the Docker website. So if you go to the Docker website over here, install Docker on Ubuntu. So here you can see Docker engine. There are so many steps. If you want to follow the step-by-step method, you can go through this process. But my recommendation is that if you want all these steps in a single platform, then you can go with get.docker.com. If you go to this website here, you can see the entire script for your Docker. Simply, if you execute this script, automatically Docker will be installed on your Ubuntu environment. I'm talking only about the Ubuntu environment. I'm not talking about the Windows environment. So let us install the Docker on our Ubuntu environment. So what I will do, I will use the AWS website, AWS as my hosting for my all the servers. Whatever the servers that I am hosting in the Docker and Kubernetes, all the servers will be hosted on AWS environment only. So it is better you have a little bit hands-on exposure towards AWS. So Docker which is a Ubuntu operating system I'm trying to install on that. And I will go with T2 micro. That's more than enough for me. And key pair will be app key. We will discuss about this AWS in the next session. Don't worry. And let me enable the public IP also. Select an existing. Why we are selecting this existing group? We will discuss about this in the next session. You don't need to worry about that. So I'm just launching the instance. Once I have deployed this instance, or else once I have launched the instance, so let us see certain changes in the server. So right now what we have done, we just created an Ubuntu mission. We just created an Ubuntu mission. In general, for this Ubuntu mission, for any computing device, what you will have a CPU, RAM, and networking devices. CPU, that is one CPU, and RAM is 1 GB RAM, and you are having certain storage. The storage that is provided by the AWS for any Linux machine is defaultly it is 8 GB, and then you can increase the storage. But the default storage that is provided by the Amazon for the Linux machines is 8 GB. And for this, you will be having an Ethernet adapter. So this is the Ethernet adapter. Why we are using this Ethernet adapter? To allow the traffic from the internet to enter into your server. To allow the traffic from the internet to enter into your server. Okay, what is the server here? This is my Docker server. Right. Now, this is just a name, but we did not install anything. So here, that is ETH0. This is the name of your Ethernet adapter. Now, if I try to log in, so I am the client who is residing on the internet. When I try to connect to my server, I can connect with the SSH. Okay. So what I will do here, let me go back. SSH-I app underscore key.pem @ what is the public IP address that is generated by the server. So here a public IP will be assigned to this server. Okay, so this is the public IP. I will be logging into the server. Okay, good. So now if you can see here in this server, we don't see certain tools. Sudo -. Look at here. If config, this is the utility, it is not available. So we need to install that utility. What this utility will do, it will be helpful for you for knowing the IP address and Ethernet adapter on your server. Okay, so if config. Now when I run, I have ENX0. So this is the name of the adapter that we are having, not ETH0, it is ENX0. So the IP address that is assigned to this particular server is, what is the IP? It is 10. If you can see, it is 10.1.2.67. So that is the private IP which is assigned. So in networking, we are having certain terms called as private IP and public IP. So right now we are having this private IP. What is that IP address? The IP address is so 10.1.2.67. Now what is the public IP? Public IP is the IP which will be helpful for the users to connect from the internet. So I want to connect to this from the internet. So how I can connect to this to the server? Through the public IP address. Everyone knows about that. So this is the public IP through which I want to connect to my server. Okay, hold on. Yeah, this is the public IP. Now this is fine. Now how many adapters that we are having in general inside the server? I am having two adapters. One is ENX0, that is our Ethernet adapter, which will be allowing the connections or else external connections, external users to access my server, and the server can access the internet. And the next one is loopback adapter. Here you can see there is LO in the sense loopback. So if you want to test any application inside the server, or else if you want to know whether the server networking functionality is good or else whether it is responding for the users or not, then loopback adapter will be very helpful for you. Okay, this is fine. Why we are discussing about that, I will tell you. Now, if you can see whether we have the Docker on this server, we don't have the Docker. So I said, so you don't need to go for everything step by step by this process. You can simply install Docker by using this particular script. Okay, here you can see curl -sl http get.docker.com. Here you can see you got all the script. You just need to install the script. That's it. So how I can install the script? It is very simple to install the script in the Docker. So how I can do that? Let us see. curl-sl get.docker.com and bash. So this will install the Docker on your Ubuntu system. Once it is installing the Docker, also once it install the Docker, then you can find out something different on your server. What happened here is, let us see what I am trying to say here. Inside this Docker server, we are about to install the Docker application. When we install the Docker application, automatically, a special device or else a special adapter will be created on the top of the Docker. So what is the main functionality of this particular adapter? What is the main functionality of this adapter? So the adapter which is automatically created, it is called as a bridge network adapter. The adapter which has been created after creating the Docker, it is a bridge network adapter. So it will be like a bridge between the containers that are created in the Docker to your external environment. So if your container inside, you are inside the container. And if you want to communicate or else there is an application inside the container. If this application has to be exposed for the outside world in the sense to the clients, then through this bridge network adapter, the data will be going across the internet. And if any request that is requested by the container from the internet, the data will be coming to your Ethernet adapter, and from there it will be going into the Docker adapter, and from there it will be reaching to your container. So now if you see here, Docker got installed. Docker info. So to get the Docker information, you can give the command Docker info. Okay, so here it is going to give you the version version of the Docker which is installed and everything. Now, if you can see Docker PS, what is PS in general? What is PS in Linux? PS will define the number of processes that are running in the Linux environment. Here also we are using the same Docker PS, number of processes that are running in your Docker environment. So processors are nothing but the containers. What are the different containers that are available in your Docker environment? So just compare both Linux and your Docker. In Linux, we will be using ps-ef to get all the processes that are running in your Linux operating system. In the same manner, if you want to get all the processes that are running in your Docker environment, you are going to provide the command called as docker ps. So it is going to display all the running containers in your Docker environment. Okay, this is fine. If config, if you can see, a new adapter is created. Previously, if you can see here, where is this? Here you can see we are having only two adapters. One is ENX0 and loopback adapter. After installing Docker, we are having one more adapter is added, that is Docker 0, which is nothing but the bridge adapter that is helpful for making the containers inside the Docker will to make the communication with the outside world or else with the internet. So this is the Docker 0 bridge adapter. So it's a default network adapter. Try to remember this. It's a default network adapter. So now what is the range of IPs that is assigned to your containers when I create a new container in the Docker environment? So this container will be communicating with your Docker network adapter. It is a gateway for the Docker containers. So what is a gateway? Anything that is coming out from the outside world or going into the outside world. So you need to have a gateway. You need to have an entrance and exit point. So here the Docker network adapter is your entry and exit point for your Docker containers. If the Docker container want to access any resources from the internet, or else if the user want to access anything from the Docker application, so from the Docker container, the data will be approaching to the internet, or else to the Docker container, the data will be reachable. So this is about your Docker adapter. Understood? Any questions here? Is it clear? Any questions up to now? We'll get back to that later. So going ahead, we'll come one by one. So if you have any further questions, you can ask me now. Do you understand what we have discussed up to now? Guys, one response at least. Hello, am I audible? Anyone, can you please respond what I said?
Yeah, you are audible.
Thank you for the confirmation. Can you please say what we have discussed up to now?
We were discussing about adapters,
Which adapters?
loopback,
Mhm.
and
What is the main functionality of those adapters?
to connect to server
Okay,
via internet or within the server.
that's okay. Now, what is the main functionality of this Docker default Docker adapter or else default network adapter of the Docker?
Sorry, I didn't get that.
What is the functionality of this Docker?
No, I didn't get that explanation.
You didn't get that explanation. Okay. Anyone? Anyone else? Okay. So now let us get back to the point. So for example, if any new container is getting created inside the Docker, okay, if any new container is getting created inside the Docker, what is the IP address that will be assigned to the container? So first things what you need to understand here is, so let us see what is the IP address range of the Docker network adapter. So to list out all the Docker network adapters, please write down these commands, very important. To list out the Docker networking adapters. So Docker network ls. If you give this particular command, then it is going to list out all the adapters that are available for your Docker environment. So one is the Docker bridge adapter, which has been just created, and the next one is host adapter, nothing but your server adapter, and the next one is null adapter or loopback adapter, which we have discussed. So the next one is, for example, if you want to know what is the ranges of IP addresses, then simply Docker inspect network or also Docker network inspect bridge. If you give that, it is going to give the full details. So the adapter name is bridge adapter and it is created at this particular time, and this is the ID of your bridge adapter, and the networking range is 172.17.0.0/16. When you install any Docker application on any operating system, you will have a default network adapter. Default Docker network adapter will be automatically created, and that default network adapter will have 172.17.0.0/16 in any environment. If you go through, for example, let me check whether I have Docker here. I have Docker on my Windows environment. In Windows environment also, if you install the Docker, automatically a Docker network adapter will be created, and that network adapter will have okay. So here you can see, let me go to here Docker ps. When I run this command, so it is going for my internal Windows Docker. So it is going into my Windows environment. Okay. Docker network, sorry, Docker network ls. So here you can see we are having a bridge adapter. So if you inspect that Docker inspect or else Docker network, sorry, network inspect bridge. So here you can see, so in my local machine also, if I install the Docker application, automatically a bridge or else default network adapter will be created with an IP address or else with a subnet of 172.17.0.0. And if you are trying to create in any another server also, it is going to get the default network adapter range is 172.17.0.0. So the default network adapter IP range is 172.17.0.0 in any environment. Okay. So now if you create a container, let us create a container in the Docker. Docker run -itd name of the container is test container. Okay, test container. And image name is, for example, Nginx. With the help of Nginx, I want to create a container. So when I try to create this container by defaultly will be created in the Docker bridge network adapter namespace, or else inside the bridge network adapter, there is a default network adapter. When you create any container, the container will be created in the default network. So what is that? So if you see here, previously we don't have any containers. See that? In the Docker bridge network adapter, we don't have any containers that are connected to this network adapter. But now if you see, there you go. So a new container is created and that is connected to your default network adapter. A test container is created under your default network adapter. And the container got an IP address 172.17.0.2. So this is the IP address of your container. So this is the IP address of your container. Let me give like this. Okay, good. So if you create one more container, if you try to create another container, and that another container will be having the IP address 172.17.0.3. So which means that all the containers that are defaultly created without giving any network adapter name, they will be creating in the default network adapter range. Okay, they will be created under the same network range. Let us see by creating another container. Docker run -itd -name test container 2, and this time I will go with the Ubuntu image. So what is this image? We will discuss about this later, but as of now it is created by the Ubuntu image. Now here you can see Docker PS. So there is one more container, test container 2 is created. What is the IP address of that? So Docker, let us inspect the network. Inspect, hold on. Docker inspect network. Sorry, Docker network inspect, my fault. Docker network inspect bridge. So now if you see here, we have a one more container that is connected, that is test container 2, that is 172.17.0.3. Now by defaultly, these two containers will be able to communicate with each other with the IP address. So if I want to log in into a container, so how many containers that we are having right now? The running containers are two, test container and test container 2. If I want to go inside the container, so the command is docker execute -it test container bash. If you give this automatically, you will be inside the container. So the point is, if you are running any container with the Linux operating system, either it might be a Ubuntu image or else it might be a Red Hat image, you can use bash. But if you are using the Alpine Linux, then you have to use sh. Depending on what operating system that you are using, you have to use bash or sh. Right now, I am using the Nginx, which is in the Ubuntu Debian only. So I am using bash. Now we are inside the container. Let us try to ping. Ping will not be available. Why it is not available? I will tell you in later session. 172.17.0.2. So we are inside the test container. So we are inside this test container. So I want to ping to the test container 2. What is the IP address of test container 2? It is 172.17.0.3. If I try to ping to that, so ping is not available. Let us install ping and apt install -y iputils -ping. Okay, so now I'm trying to install the ping. So after installing ping, I will try to communicate to the test container 3, 172.17.0.3. So now I am getting the response from the opposite container. From the another container, I am getting the response. So these two are getting communicated with each other. But the main point is, if I try to communicate with the name ping test container test container 2, then see, with the name we are unable to communicate. Why? By defaultly, if you are using the default network adapter, or else if the containers are under the default network adapter, the two containers will not able to communicate with the name. So if at all, if they are with the external adapters, if they are with any external bridge adapter, or apart from the default bridge adapter, if the containers are created under an external network adapter, then they will be able to communicate with the name. So the first things first, what you need to understand, any containers that are working under the default namespace, they will not able to communicate with the name. And if they are created under any external bridge network adapter, they will be communicating with the name. So this is the main point that you need to understand. So that's about here. I will stop, and tomorrow we will see about the external network adapter and what are the different Docker lifecycle and Docker architecture that we will see in the next session. So if you have any questions, you can ask me now. And before you are asking me, let me explain you the timings. The timings will be from 7 p.m. to 8:30 p.m. 8:30 p.m. So the demos will be continued up to 7 to 8 o'clock only. And later from Monday onwards, the timings may be changing. I'm not sure about that, but they might be changing. That is from 7 o'clock. Even though the extension, there will be time extension will be there somewhere around 8 to 8:30, but the class timings will be starting at 7 o'clock. So, and the next one is it will be some 20 to 25 days of session, which we are going to conduct across the Docker and Kubernetes. Okay, so that's it. That's it from my end. If you have any further questions, you can ask me now.
Just one thing,
Mhm.
that when this course will end, means we will know that how to write the Docker files for any application, right?
Sorry, come again, come again. I'm really sorry. I did not understand that.
At the end of the course, we will know how to write the Docker files for any application, right?
Yes, not at the end of the course. In the beginning 3 days, like from on Monday or Tuesday, you will come to know about how to write the image file for the applications. It's not
Okay.
very big task for you. At the end of the course, you will be, I will not say you will be expertised or perfect, but you will be professionally okay with your Kubernetes and Docker. Okay, it's very simple for you to write the image files. Yeah,
Okay. Okay.
cool. Any another questions?
And, this is like too much information for me when I'm attending for the first time actually. So,
Sorry. Your voice is very low. Can you be a little louder?
hello.
Yeah.
Yeah, yeah. It's like it is too much information for me. I'm listening for the first time. So
Mm-hmm.
yeah. If I join the course and the other things will be covered, right? Continued. So this is like uh, you are going to you are explaining the in high level, so that all the other details will be covered in the course, right?
One second. So I didn't go for very high level. Okay. I'm just explaining you in a very low level in a Linux operating system what you will have. Of course, applications will have. Inside the application, you will have the process running. So those processes are nothing but the containers. The basic thing. Everyone knows who know about the Linux. And the next one is I discussed about the networking. It is a little bit difficult for you. Okay, networking is also basic. I'm not going very in deep into the networking. I'm saying that if you are running a container inside the Docker, if you are running multiple containers in a Docker, how these two containers will communicate with each other. Apart from this, I did not go very in deep into the concept. It is not a high level thing. I don't know. Maybe you might be facing that particular issue. Uh, let us see, and we will try to rectify the issue very keenly when we go inside the Docker comp. Okay.
Good. Thank you.
Yeah. Any further questions?
We are going to revisit these concepts in the regular course, right? Or this is like
A
pre-end.
regular course, we will
This,
slowly go into this.
Mhm.
Okay.
Okay.
So why, if I have to say, this is the second demo. If I have to say, I can repeat the same concept which I have said in the last session also. But I don't want to do that. Why? Because you will get bored. How many times you will say the same? I cannot do for going ahead of syllabus and everything. So at least I need to start certain things, right? Docker and how it is going to function. So I said you that. Let us see if I go into the main sessions like on from Monday, how we are going to discuss. Okay, how either I can repeat the concept again back. Okay, it is not a very big deal with this. Okay, right. Any further questions about? I just want to know how many people are working here, or else before you give your answers, that's fine. I think there are majority people are saying that like, see, I took somewhere around some 25 batches. Everyone in every 25 in every batch there are people. I'm talking about the Docker and Kubernetes only, not about AWS and DevOps. Anyways, coming back to the point here, there are so many people who are from the Java background. There are the people who are from the non-technical background. So no need to worry about that. Definitely you are going to get whatever the knowledge that you are requested for. Okay. So yeah. So I know that there are so many people who are from the working background. So why you want to learn Docker and Kubernetes? What is the necessity? Already there are some people who already explained me about that, and those who didn't, can you please explain me why you want to learn Docker and Kubernetes?
This Docker and become the industry standard, right, for deploying all the applications. So it is become a prerequisite for us to know at least the details of that.
Sorry, come again.
Yeah, this Docker thing has become a means it's a standard, de facto standard for making containers. I think as many of the companies are following this Docker thing, and for handling this images in the Dockers, we need to have the Kubernetes knowledge. So how we are going to deal with these containers. So
See, to handle the Docker, see, Kubernetes is not required to handle the Docker images.
Mhm.
Kubernetes is required to handle your application containers or else application pods, to manage your pods, not for the images. Okay. So image store will be different. Whatever you are talking about the Kubernetes is a management tool where it is going to check out all your applications lively, whether it is going to, whether the applications are running properly or not. If one application is down, how to bring back that application automatically. So how we are going to go for the deployment. So these are all the things will comes under the Kubernetes. So it is not for the image storing purpose. Okay.
So that on basic note, actually, so we are using different tools like AWS, Azure, right? So
Mhm.
means knowing this means internally they are using Kubernetes, right, to manage all the our applications.
You are talking about AWS cloud-based
Correct.
Kubernetes, cloud managed Kubernetes, or else managed Kubernetes.
Means internally they'll be using Kubernetes to
Who will
manage.
be using the Kubernetes? AWS. You are talking about the
Correct.
AWS.
Correct.
How can you say that they are using the Kubernetes?
Internally they'll be using means they are also managing our applications, right? So they will be internally using Kubernetes to handle our applications.
No, they will be having a separate service for that. Okay. There are certain tools in AWS itself to run the Kubernetes or else to handle your application. If you want, you can configure your application in the Kubernetes that is managed or that is hosted by AWS. So now what you are asking here is if I'm going with a PaaS model or SaaS model in AWS, then they will be managed by the Kubernetes application. How can you confirm that? I don't know how they are managing. In the backend, they will be running certain servers. Okay. So Kubernetes is, I cannot totally agree with whether they are going with the Kubernetes. But if you want to manage your containers or else your application in AWS, you can go with the Kubernetes platform that they are providing. Okay.
Okay, but if we are using these AWS or Google GCP as usual, so knowing Kubernetes is optional, or we need to know them Kubernetes as well to work with them.
That's a separate discussion. We'll discuss that later. Okay, so AWS is a cloud platform and Kubernetes is separate, totally a containerization, container management platform. Okay, how you can connect both the things?
And it's knowing the Kubernetes knowledge will be applicable, will be helpful in knowing them as well, or it is totally different thing.
Your voice is breaking out first. Can you please talk a little bit louder so that I can answer your question?
No, actually, how the Kubernetes knowledge will be helpful in knowing in working with the AWS and GCP, something like that. So will it be helpful to work with them?
See, we are working with Kubernetes that are running in AWS. Okay, we are not see AWS is an infrastructure platform. Simply, if I have to say, uh, if you are purchasing a car, okay, you are purchasing a car, and you are the manager of that particular car. Whether you are going to choose on which platform the car is built, okay. So whether that car is having, so there are certain platforms to build the car. Okay, so different companies will use the different platforms to build the car. Are you going to use that platform or else are you going to use the car, the application, right? So here AWS is like an platform to build your Kubernetes. Able to understand here. So with the help of Kubernetes, what you are going to do, you are going to manage your applications. Okay. So it is very important to know about the Kubernetes platform on what you are running your applications. In the back end, you are having a cloud support. Okay, so that's the base for your entire Kubernetes. But here you are comparing both the things, AWS or Kubernetes. AWS is an infrastructure management or else infrastructure provider. Okay, AWS is a cloud service provider where it is going to provide all the resources and services. Kubernetes is the management application management platform. So here there is no comparison between AWS and Kubernetes. Am I clear with this?
Yeah. Yes.
Okay. Any further questions? Fine then. Have a nice day and we'll meet in the next session.